So today we are moving beyond simple spreadsheets. We are building a high performance forecasting ecosystem that pits five world class architecture against each other. So by the end, we exactly see how to determine which model, be it a transformer, a GNN, or a deep AI LST. So let's start. First is the interactive feature. So this is the single file feature. We have started by building the foundation. Beyond standard inputs with pandas and dots, we have included detailed single file function using Tinker. We created an interactive GUI pop-up that forces a single file selection for each dataset. This isn't just for convenience. The script actually clones the selected files into local directory. This ensures that even if you move your original files later, the project remains fully recorded as self-contained within the folder. So now this is our single file picker function, as you can see, and this is the vendor sales summon which we have taken as input from the past. So this is a little bit of helper function. So now dynamic data loading is into time frames. So here we load the vendor sales summon CSV retail data to check that the retail data is not always for missing time zones. So we added a safety net here. If the script does not find a column containing the word date, it doesn't crash. Instead, it uses ed.daterange to generate a synthetic weekly timeline starting to January 2020. This allows us to apply time series logic even to static dataset, ensuring every row is mapped to a consistent temporal index. So next is this is a PDA. As you can see, you have already seen our EDA before. So now, this is building vendor time series. So raw data is usually flat. By forecasting models with sequences, our build vendor time series function performs the heavy lifting. It groups the entire dataset by vendor number and resamples the data to a weekly frequency. Crucially, we use S frequency fill value equal to 0 in retail. A missing value usually means zero source, and the function ensures our top 40 vendors have a continuous unbroken single for the neural network to study. Then this is from where we have started the tool training. Means basically it is the start of the machine learning models of used. So first, the pooled LSTM. So our first deep learning approach is a pooled LSTM, where we are using the Dart libraries. And we don't train 40 separate models. We train one model on the top 12 vendors simultaneously. This is a global strategy. It allows the LSTM to learn shared seasonal behaviors like holiday spikes or month-end peaks that are common across different vendors. We also implement a Gaussian likelihood, which means the model isn't just guessing a number, it's estimating a probability distribution. So there is the output you can see of full LSTM. Then it is basically a twin test splitter that commonly seen in various deep learning or machine learning projects, where we do this for making the data as simple as possible for the next steps. So now you can see the the compute baseline for top vendors. So before we get a fancy, we need to prove our AI is actually useful. We split our data into training, validation, and a 52-week test set. Then we run our baselines on naive forecast, a moving average. This represents the simple logic possible. If our neural network cannot outperform this number, image or MEP, is a sign that the data is either too noisy or the model needs more tuning. So this is the complete baseline model, and now we will move to temporal fusion transformer. This model is multi-bit, meaning it looks at more than just passive. It extract month, week, and day of week as known reals. The PFT uses an attention mechanism to look back at 12 weeks and identify exactly which point is in time are the most predictive. We use quantile loss here allows us to generate hidden and penalty forecast, essentially best case and the worst case scenario for inventory planning. So here is the PFT, and this is the number of weeks as I told. So now we will move to further another step of full DPR like RNN, where we have run 50 epochs only once. You will see a second LSTM. So this is a DPR style implementation designed for a much deeper training cycle. While the first pass was a quick loop, this cell run for 50 epochs with a 128 dimension hidden state is designed to capture more complex nonlinear patterns across the vendor. We save this result to pull deeper results.csv to see if more depth and time actually translate to better accuracy. So there is the frame ones and the pre-vendor evolution as you can see, and the output saved as full deep result.csv. So now we will move to NVIDS. This NVIDS is a single decomposition model. This NVIDS actually is famous for beating the E4 forecasting competitions. Unlike in LSTMs, NVIDIA stacks to fully connect layers. It works by subtracting the trade from the signal, then subtracting the seasonality, leaving only the residual. We use this model for vendor using a PyTorch Lightning progress bar to monitor the fitness of the model as it iterates through our top selling vendors. So this is that in this, and as you can see here is the result we are talking about with this thing. So now it is basically the GNN model. Yes. So graphical neural network, the correlation also called a correlation model. This is the most unique part of our Python. We treat our vendors as nodes in a network. We calculate a correlation matrix across all sales history. If vendor A and B have a correlation 0.40 or higher than this, we draw a link between them in an adjacent matrix. Our simple GNN then performs graph convolution. This means the forecast for a specific vendor is actually informed by the sales rate of its most simpler timers in the market. So basically, this will connect each and every vendors where the vendors will share their data, and according to that, prediction will happen. So here are the inputs, and GNN matrices which are saved in GNN result.csv. So according to these previous GNN matrices, we have find the top vendor series is total features, so feature matrix shape. So now the CVA for vendor anomaly detection. So first of all, CVA is known as convolution variation autoencoder. We don't just plug the data, we audit it. We build a CVA as an anomaly technique. It learns the latent representation of a normal cell signal. After training, it tries to reconstruct the data. If the reconstruction error is significantly top or more, then 1% flags the date. Flag the date and vendor as anomaly. This is perfect for catching supply chain disruption or data entry error that would otherwise ruin your forecast accuracy. So here you can see the steps. We have convert the NumPy adding sizes. Then we have applied the CVAE model, and then we have prepared the tensors and the data loaders. We have trained the loops. There are 50 box in total. So here is the output of it. So now is the performance matrix comparison. So here we have take the output of each model, and we aim is making sorry so we have first compared every output in this code. You can see the pooled LST, the NBs, the TF2, the GNN, CVA. This is not for forecasting, but it is a quite good model. And then the final comparison table. So now we will create a virtual visualization dashboard for our model comparison. So a table of number, is it enough for a presentation? So we finish with a full visualization suite. We generate bar plots for raw error, but more importantly, our radar chart. The radar chart shows the balance of the model. So here is a code, the radar chart, rank chart. Here is our output. These are the bar charts. So we generate bar charts for raw data, but more importantly, our radar chart. Here is the radar chart. This radar chart actually shows the balance of a model. So finally, the rank chart averages all matrices to give every model a final Olympic standing, all of which are saved as high-res pages in our result folder. So in conclusion, we have covered everything for raw data training to advanced graph-based deep learning and automated anomaly detection. The beauty of this workflow is that it does not just give you a forecast, it gives you the best forecast by testing multiple things. You can find the full code in our description. Don't forget to check your results folder for those performance charts.